welcome back to our Common Lisp video series. I'm just going to zoom in a wee bit there. Last time we started looking at object orientation in Common Lisp, and we started with structs, and we are going to continue looking at classes now, or at least an introduction to classes, because there's a lot more to classes going on than initially seems, and it's certainly very different from other languages that you may or may not be familiar with. I come from a Python background, so Python Java background, so when I first started learning about this, I had a very clear idea in my head about what I thought object orientation was about, and as the years have gone on, I have learned that there is no one way to do OOP. Excuse me, sorry. You know, we look at things like Java and C++ before that. These languages that have a very clear idea of what they think OOP is, and then you go back further and you see things like early Lisp libraries and back further, and we get to progenitors of all this, Smalltalk and Simula 2. They had a very different interpretation of what they thought object orientation was, and Common Lisp is probably one of the languages that is closer to the original idea, but it's not quite there, but it does look different to how, I hesitate to use the word modern, but as of 2020, relative to 2020, it looks quite different to how you might expect classes to work. Sorry, excuse me again. Really need to drink more water. Also, programmers, drink more water. Anyway, we deal with classes and object orientation differently in Common Lisp, and we're only going to have a look at data here in this session. So based on what we learned last time, we could create a struct with def struct, so it should come as no surprise that we could create a class with a def class. Give it a name, and that is the label of the class. The next thing that we do is give it a list of direct superclasses, which, as you can see in the bottom left, is what we're doing. We are not going to have any superclasses, so we have an empty list here. Now, the next thing is the slots. Now, structures had slots, classes all likewise have slots, and the easiest way is to just do something like name and age. And if I compile that, you can see that creates a class. But this is not really good enough. It's not practical for anything. So we need to break these slots up and provide some more information. So if I do this, right, fine. Go. Sorry, I had an unbalanced parentheses there. We can split these slots up into individual things here, but again, this is still not enough. What we actually need to do is be able to give these slots some values when we create them. So we need to do there we go. So we've got in. I keep doing this. I think this is muscle memory. Arg is not a word I type particularly often, and certainly when I'm writing in the context of age there. But init arg is a keyword that we pass into the class constructor. We can use init arg and then following that is another keyword, but this is one that we defined. We say :name or :age, and if we compile this up here, we've got a perfectly valid class, so we can create an instance of said class, and I'm just going to call that instance P. And if you're coming from another language, you might reasonably expect that you use new. That's not necessarily the case here. Or if you come from Python, you might think that we just call the class as is. That's also not the case. We use a function called make instance, and it takes a symbol, which is the name of the class, person, and then it takes keyword arguments for the slots that we've created. Yeah, I'll do. So here, what we have is the ability to look in and get the slots. Now, we create our person with P, with make instance, the symbol of the type of the class that we want to create, and we use this :name, the symbol here, keyword, sorry, this keyword, because this is the initial argument to the constructor, and it's the same with age. We pass an initial argument, so we must pass a :name with a value and a :age with a value, and then we can use this macro here with slots, and we specify the slots that we want to use, in this case name and age, on the object that we want to get them, and then we can use name and age as references to the slots on that class. And that's certainly fine, but there is more that we can do here. So we're just getting rid of this with slots business. And what we can do is, if we pass in this reader keyword here, and I'm going to make sure that we've compiled that, and we run this code here, we get exactly the same as we did before, but we don't have to use that with a slots macro. What we can do is we can define readers. And readers are functions that get created for us that allow us to access data in a particular class. Now, there's a problem here. We can't actually change data in this instance. You know, if I try and do this, this is not going to work for me because you know, it doesn't work. We don't have a way of using setf on these things, at least not natively. But what we can do is, in addition to reader, we could say really hoping I've got these arguments the right way around. Yeah, I'm pretty sure I've got the arguments the wrong way around, although that doesn't work either. Oh, of course. I forgot to change my readers. I do apologise about that. But this works now. You can see that we now have this set name function that now exists on our class, and we can use that to actually change data in our class. However, if we are creating both readers and writers, and it's important to know, you can have as many readers and writers as you like. So I can do this business here and change this back. And as long as I compile this up, I can run this and it'll work just fine. So you can have as many readers as you like, and honestly you can have as many writer methods as you like too. Presumably if you're wanting to build some sort of interface that conforms to the principle of the least surprise, you might want to create these reader and writer methods. I'll say methods, these functions that operate on objects, so people won't be surprised with how they should interact with your object. But really, if what you want to do is create a means to both read and write to an object under a very simple interface, what you can do is you can set an accessor, and we'll get rid of these. What we have here, and so I'm going to recompile my class there, and then I'm going to run this, and this works exactly as we expected it to. So if we set these accessor methods, we can use setf. Remembering that setf sets a field, it then takes a pointer to some sort of thing in an object and then sets the value of that. So we've got this very common Lisp-like interface that we might use on a list, on a hash map. We can use it on classes here too, so we can plug into the existing common Lisp API, and I think honestly that's better because it allows us to create a very common Lisp-like abstraction over our own custom objects. And I'm a big believer that if you can make your own classes and objects behave seamlessly like they're part of the programming language, that's probably better, because the user of your code, the end developer, does not have to learn your own idioms for your own API. They can use the idioms that exist in the language, and it conforms to the principle of the least surprise, which probably sounds pretty conflicted now. I should state that I believe that you should learn a language and its idioms well, and that means that nothing in a language comes as a surprise, so that when developers and third-party libraries behave like the language behaves, you can just use them without having to learn special syntax or special API calls. Things just seem like an extension of the language rather than their own thing. So we've had a look at reader, writer, accessor, methods, we've had a look at init arg, and what we can do sorry, my throat's quite dry. I have been teaching all day and now I'm making a video, so do forgive my coughing. I'm not sick, I'm just a little bit dry throated. So we have these init forms as well here, and what init forms allow us to do forgot to recompile my class, sorry about that. So init form, again, another keyword argument that we can use in our classes here, followed by some sort of value, allows us to give our classes default values or initial forms, remembering that forms are anything in Common Lisp, including values and function calls or objects or anything like that. Those are forms in Lisp. And by setting some sort of initialization form, if we omit the initial arg or the init arg, the init form will fall back and fill in that default for us, which is pretty cool. But if we take this line away and do this, we can see that we get our name passed in, and the init form does not apply here, but the init form for the age does. So init form is pretty cool. It allows us to assume some default values that we can override if we choose to. And there's really not a lot more to classes, really. There's a couple of things that we can discuss here. So if I compile that and run this now, everything works as ever it did. But if I run this, we get 145 as a value, and not Bob or anything like that. And you may be confused that we're saying type is string. We're passing in an integer here. The important thing to be aware of is that this type is not enforced. It is actually a hint to the developer reading your code of what type of value should be stored in this field, and if they don't do it, well, that's kind of sort of on them. But it's expecting a string, it's expecting an integer, and anything else that operates on this is operating under the assumption that the data is a string or an integer, but it does leave it up to the programmer to enforce that, and if they don't, well, I guess that's on them. Additionally, we can pass in some extra data here. Again, we can use this documentation here, and that again provides some hint to the end user, the end developer here, about not just what type of data this is, but what the purpose of storing the data as that is. So both type and documentation are therefore programmers' sake. None of this is enforced. It's just there so when people are reading the code, they can see what this is and why it's supposed to be there. And certainly the type tripped me up. I naively assumed that this would enforce types, but it's not the case. So that's what these two things are. So we've got 1, 2, 3, 4, 5, 6, 7. We've had a look at the reader and writer that aren't here, so that's 7. There are actually 8 things to be aware of here. So we're going to create a new there we go. I'm doing init age again. So we're just cleaning this up here. So if I recompile, it's the 8th thing, because there are 8 things that we can use when building a class here, is allocation. And there's 2 things. We can either use class or instance. So if I wanted to, I could put this here. Recompile this now and run this, we can see that human is listed here in the bottom left. Now what I could also do is I can create a second person . And what I'm going to do is I'm going to say setf species p not human . So in principle, I'm changing the species on the P2 instance, but evaluating here, when I do that format nil business on line 13, I'm only dealing with the P object, not the P2 object. But nevertheless, the P object, or it's because it's a species slot, was class allocated. Slots that have class allocation are shared amongst all instances. So if you have some shared state that you need to change, you can do that. The thing is, this applies for stuff that doesn't even exist yet. So I could do let p3 equals make instance person name Fred, age 34, so we can see this is an entirely new block with an entirely new instance, but nevertheless we can see that even though we changed the P2 object's species to not human, every other person class now has that species property changed. So those are kind of the 8 properties. So we've got init arg, init form, accessor, reader and writer, and we don't have any reader and writers here anymore, but we did allocation, type and documentation, and those are really the 8 kind of slot types that we have. And there's more that we can actually pass through on a class itself, and we will get into that in a different video. So I'm going to save this file here, and we're going to have a look at classes themselves a little bit in the next video, the sort of things that we can add to those. We're going to have a look at meta classes, and the one thing that you may have noticed here is that we've not even looked at methods yet. You know, we've just looked at properties or slots, but methods are, spoiler alert, completely independent of our classes. They're their whole thing on their own, whole own thing. And that'll take a video in its own right to look at these. So at the moment we're just going to have a look at how to build a simple class with some simple slots, how to use that with slot macro we saw at the beginning, how to use these 8 things, and just kind of appreciate that for what it is, because the rest of classes will require certainly a couple more videos. And that does not even necessarily mean we're done with object orientation in Common Lisp, but yeah, I hope that quick whirlwind tour has been interesting. I hope we've seen how we can build simple objects here, certainly with slots, and look forward to seeing you in the next video. So take care, everyone. December is a busy month for me. I don't know how many more videos I'll get out this month, but I will certainly continue putting these out as soon as I can. But, you know, December 10th, not a lot of time left, and it's graduation week at the boot camp I work at next week, so please bear with me if there's no new videos this month. There will be some in January, I do, if nothing else, I do assure you. But take care. If there's no more videos, have a Merry Christmas, have happy holidays, or if you celebrate a festival I am not aware of, please have a wonderful time with your friends and family, in so much as we are all able to in 2020. And see you in the next video.